Going on, guys? In this video we are going to see an example on using the method of reduction of order, and here we have the question that's asking to find out the general solution and the second solution of this differential equation, and also they have given the y1x is equal to x square. And before we do this problem, let's look at this information about this problem. So here they are saying when we have a second order differential equation, since p of x, q of x and r of x are not constants, we cannot use a characteristic equation. To use the method of reduction of order, we must be given one solution to the differential equation. The method of reduction of order is a method to reduce second order differential equation to a linear first order differential equation to help solve the differential equation. We start by assuming the second solution will be in the form of y2x is equal to u of x y1x. So we have to assume this y of x is a function of u of x and y1x. Here y1x is x square, so I plug that one right here, and we have to know this is a function of x. That's the main thing. And after that we can write this one as ux square. Now we have to plug this one back in this equation, but we have to, in order to do that, we have to find the first derivative and the second derivative. Now let's check the first derivative. Y prime is going to be, so here we have both of them are function of x. This u is a function of x and x square is a function of x, so we have to use the product rule. So first I find the derivative of u, that's going to be u prime, and I keep the x square as it is, and then I find the derivative of x square, that's going to be 2x, and I keep the u as it is, so that's going to be 2xu. And when I take the second derivative, again it's going to be a product rule. The first, if I take the derivative of this one with the u, that's going to be u double prime, I keep the x square as it is, and then I take the derivative of x square, that's going to be 2x, and I keep the u prime as it is, that's going to be u prime, and then here again I have to use the product rule, so this is going to be 2u and 2x u prime. Okay, now let's here we can add these two together because 2x u prime, 2x u prime like terms, so we can add them together, and that's going to give us u double prime x square plus 2x u prime, actually 4x u prime, because 2x u prime plus 2x u prime, that's going to give us 4x u prime, 4x u prime plus 2u, 2u. Okay, now what we have to do is we have to plug it in this equation. So x square times 4x u prime plus 4x u prime and this one u double prime x square. Now let's keep it in the order, as it is. So x square times u double prime x square plus 4x u prime plus 2u, so this is y double prime, minus 3x, and y prime is u prime x square plus 2xu, so this is going to be u prime x square plus 2xu plus 4y, so 4 times, we know that y is equal to ux square, so we can plug it right here, ux square. Now let's simplify this one. Okay, and this is all equal to 0. Okay, and let's simplify this one. So if I multiply this one with this, that's going to be u double prime x power 4 plus 4x cube u prime, and here we are going to have 2x square u, and here we are going to have negative 3x cube u prime and negative 6x square u, negative 6 x square u, and here we are going to have plus 4x square u, that's equal to 0, and let's cancel everything we can cancel. So here we have negative 6x square u, 2x square u, 4x square u, so these three cancels each other and we are left with this one, and 4x cube u prime minus 3x cube u prime, that's going to give us 1x cube u prime. So final answer is going to be u double prime x power 4 plus x cube u prime. Now this is in second order. Now to simplify this one, what we are going to do is we are going to assume that w is equal to u prime and w prime is equal to u double prime. Now we are trying to bring this one into first order linear differential equation. So now let's go ahead and plug this in this equation. So w prime is u double prime, so this is going to be w prime x power 4 plus x cube. Instead of u prime I plug the w, that's equal to 0, and now you can see this is a separable differential equation, so we can separate and integrate. So if we separate this one, this is going to be w prime x power 4, and instead of w prime I can write it as dw by dx, so we can separate the like terms together. So dw by dx x power 4 is equal to negative x cube w, and here we can bring the w's together and x together. So here if I bring this w to this side, that's going to be 1 over w dw, and in the other side we are going to have negative x cube divided by x power 4, that's going to be negative 1 over x and dx. And now we can go ahead and integrate this one. So I'm going to integrate here and also here, and this is going to become ln of w, and in the other side we have negative this one, so that's going to be negative ln of x, and also we have to put a constant. Let's say constant is c, and now to get rid of this ln we can e power all of them. So let's e power everything. So this is going to be e power this, and e power ln of w, that's going to be just w, and here we have e power negative ln of x. I can move this negative to the power, so we can get rid of this ln of x, right? So if I move the negative to this power, so this is going to become e power ln of x power minus 1, okay, plus constant. And when we have the powers adding together, it means it's multiplying. So we can write this one as e power ln of x minus 1 times e power constant, okay. So from this one we can cancel e and ln together, so that's going to give us x power w is equal to x power minus 1, and e power constant we can equate this one to another constant, like e power constant is equal to c2. So instead of e power constant I can just write it as c2, and I can rewrite this equation as c2 over x. So that's going to become w is equal to c2 over x, okay. So now we have found out this relationship, and we have taken w from u prime, we equate u prime to w, right? So now we have to bring this one back, and this is going to become du by dx, okay. Du by dx is equal to c2 over x, and again this is separable, so we can separate and integrate. Now let's go ahead and separate this one. This is going to be du is equal to c2 over x times dx. Now let's go ahead and integrate this one, and integrate this side, and integration of du is going to be just du, and integration of 1 over x is going to be ln of x, and this multiplied by c2 is a constant, so c2 ln of x, and also we have to put another constant, let's say that is c1, okay. Now this is our final answer, but we have to write this one in terms of y of x. So and we know that y of x is equal to ux square, so therefore u is equal to y of x over x square. Now to write this one I need some space. Let's get rid of this part, okay. Oh, I need this one. Let's get rid of this part and continue this one right here, okay. We know that u is equal to c2 ln of x plus c1, so this is what we found out, and from this one we know that u is equal to y of x over x square, y of x over x square is equal to c2 ln of x plus c1. Now if I bring this x square to the other side, that's going to become y of x is equal to c2 ln of x plus c1 multiplied by x square, and if I multiply this one with this x square with this one, that's going to become c2 x square ln of x plus c1 x square, okay. So this is our general solution for this differential equation. Now here in the question they have asked to find the general solution. Also they have asked us to find the second solution. So from this one you can see the first the given solution is here, this one, right? So they assume c1 is equal to 1. We can take any constant, so c1 is here, they took c1 as 1, and that's why we have x square. And for the second solution we can also take any value for the constant. Let's take 1. So if I take 1, this is going to become y2x is going to become just x square ln of x. So this is going to be the second solution for this differential equation. And that's how we do this kind of problems. I hope this helps. Thanks for watching.